All right, so what did you guys want to go over
Is that
today?
like what we're getting tomorrow?
We should print out the study guides for like our final.
Mm-hmm.
So we have like the whole like PSS thing.
Oh, that's even for tomorrow. You have that?
Yeah.
Like for lab?
Wow.
What?
Yeah. For,
Oh,
like,
how'd
the
you get
lab.
it before?
Did you just ask him?
Yeah, I just emailed them.
That's awesome.
Oh,
I didn't
nice.
think
Can
about
is there a photocopier? Like, is there a print thing that we could go print it? We could go.
I
Print
could
it
just
out.
email it to you.
She just emailed it to me, so can we
Okay.
go print it out somewhere?
that.
Or we print it
Yes. There's a printer right inside like the learning center area, like right through the doors. We
Mhm.
just walk down to the left. You just like send it to your like printing thing on BSU. On you know the, do you know what I'm talking about?
No.
The
Nope.
mobile device printing thing, and then you just
No,
swipe
I
your
haven't.
card at the printer, and then you can print it from that.
Do you know? Okay.
I don't know how
We
to do
could
it.
probably just print 3 for one person, so we don't all have to
Mhm.
go.
Yeah.
But I don't know how to do that. I'm sure I can ask.
Like the
them
one in the
already.
library.
I've never
Yeah.
done it.
Well, all you have to do is go.
So like if I have it on my
Whatever I want.
email, then like what do I do?
So download it.
Okay.
I need to go over Alex.
Okay. How many topics do you guys have left to do?
I'm done.
Nice.
You finished all your Alex?
Yeah. Well, it's I have the last
I
one,
have
chapter
done mine
6.
the last like 3 weeks.
You done with your like circle?
Hmm?
You done with your like pie?
I'm at 96.
I don't even know how many I have.
Just download it.
Okay. So it's here. And
I like
then-
panicked and did it all Sunday night.
Oh,
So did
And
I.
then see it done. And then he was like, "Oh, I reopened it."
You have
And
to
I
like
was
download it into like a file on your computer.
93. So right now
I
I'm
don't
on
know.
the
It's probably
objective
in your
knowledge
downloads.
check, and then after that's chapter 6, and then we're done.
Downloads.
Okay,
Yes, yes. Okay.
So go to bsu.edu.
It's kind of like nice though that if we don't do it, we can still get 100 on
How?
it. Isn't it? Because he just takes the pie chart.
And then search
I think
printing.
he takes the assignments and that's what he grades. I mean the
There
pie
might
is
be a
a part
different
of
way,
it,
but
but
I
it's
just
not
don't
like.
know how to do it.
He doesn't. I don't think he grades anything because you just
And
have to get
then
it
the
right, and
first
that's how you
link.
move up in the pie.
Yeah, but I don't think
And
like you
then
have
mobile
to. I
device.
don't think you have to finish the pie.
That's
I don't-
finishing the course.
So then you
have to
sign
finish the
in
course.
and then you upload that
That's a
file.
course,
And then
but
you
he
can
has,
go
like,
to
assignments
the
he
printer and
gives.
swipe your
I think
ID
that's what he takes.
and then
isn't
print
it?
it.
I don't know.
But I could be wrong. I don't know.
I have no idea. I'll
Okay.
probably end up emailing him.
So we can work on the review for the test, and then if you want to work on Alex while we're doing that, or if you want to do this first, then we can go over Alex later.
Why don't while we're waiting for that to print, we start doing Alex?
Okay, we can do that.
Okay.
I'm on a knowledge check, so knowledge.
Yeah, I'm on my knowledge check too. Just locked up.
Okay.
This is just gross.
Okay. I don't know how to do this. Let's check.
Okay, so we're doing molecular orbitals.
Make more than one copy.
Okay, so for this one,
Oh, you're supposed to select it.
I would need 3 copies.
1, 2, 3. Does he need one?
I got one.
I have one
Okay.
too.
You do.
Let's make 3 just for
I would suggest, oh wait, this is a knowledge check.
Yeah.
Okay, so you can't like press explain and then
Yeah.
look at it. So you just kind of have to go
How
over
much
it.
is this?
It's only 135.
Oh, good.
Did you do it?
So do you know the shape for sigma and pi orbitals?
I'll come with you.
Like,
We're
remember
gonna
when
do
you, like, the last test you had like the graphs and you had to draw like the circles or the lobes, that kind of thing?
Yeah.
Okay. So what does an s orbital look like?
Just one big circle.
Mm-hmm. And then the p orbitals are what?
The like smaller ones.
Mm-hmm. So the sigma corresponds with s and the pi corresponds with p, I believe. And then, do you know what the asterisk means? The asterisk indicates that it's anti-bonding, so if they're like connected, they're bonding, but if they're all separate, they're anti-bonding.
Okay. So it was separate then?
Yeah.
Okay.
And so would you say that's S or P?
Would it be P?
Yeah, I would say so.
Is it just P? Then?
Okay.
Or-
Does it say that a number? What does it say at the top there?
It just says study the following sketch. It was run by 2P atomic
Okay.
orbital.
So you would use that 2p. So 2 would be your first. Because we have to have a number and then the p. And then in like the subscript, you would do the corresponding, the sigma or the pi or the asterisk, depending on what this is. So we decided that it's,
So it would be like 2P and then like this,
mm-hmm.
an asterisk. What the heck?
We would either put the sigma or the pi first. So 2p, and then we decided that it was pi bonds, right?
So it's just pi?
Pi, and then if it's anti-bonding, we put the asterisk as well.
At the top? Or at the bottom?
I don't really remember, to be honest.
Do you remember that? Did you do this yet?
Is that? I did do it, but I totally forgot to do it. Yeah, I couldn't tell you, to be honest.
I'm just gonna get it then.
Yeah.
Basically.
I might try to look it up, but... And I think that's just like an Alex thing. Like, I don't know if that's even going to be something on your exam.
A lot of the stuff that's on the side we have an exam.
Yeah.
Yeah.
It's-
So,
It's like redundant to do.
Do you have to do Alex? And
no, we had a different program.
'cause I was gonna ask you if we have to do the whole circle, because like we have this big circle.
I'll just email him and then I'll let you guys know because I really hope not.
I have no idea.
I don't think we.
Here's yours. It's your help.
Oh, awesome. Thank you.
Yeah, if we get this done, then that means lab tomorrow is gonna be slightly short.
Yeah, staying in there the full 3 hours was always,
The worst.
yeah.
How'd you guys do on your quiz?
Pretty good.
I didn't look at it.
It's basically like everything he gave us,
Right.
word by word. So
Does your lowest quiz get dropped still?
Yeah.
Okay,
Yeah.
that's good.
Which is very helpful.
Yeah, definitely.
all right, you guys ready?
Yes.
Yep. All right, now I really feel like I'm back in Gen Chem. I have my own worksheet. Oh, this actually might help you on the Alex problem. There's like the symbols here.
Oh,
So
yeah.
one of these might correspond with one of those.
Okay.
So look at this maybe. All right.
So if we do this, which gas it is.
Circle the set of conditions under which a gas would be expected to behave most ideally.
Isn't it high temperature and low pressure?
Yeah, it was one of the iClicker questions,
Mhm.
wasn't it?
That's why I think it's high temperature, low pressure.
High temp, low pressure.
Mm-hmm.
Does this have to do with the ideal gas law?
I think so, because this is ideally,
Yeah, it says-
but
Right.
which I don't know that.
Say if your notes say high
I'm
temperature,
gonna
low
look.
pressure, then
I think I wrote that down.
I know, that's why I think.
I know it'd be high temperature because gas molecules are always like moving fast.
right.
More temp equals more energy, so that's correct. But then
High temp, low pressure.
Yeah.
Yep. Yes.
For the following questions, respond using one of the 4 options.
This would be helpful to have your gas law notes out for this too.
I don't know how you're supposed to figure this out.
So for A, we have 1.26 moles 22 degrees Celsius, 780 torr. Volume and temperature are kept constant. We're adding moles. What will happen to the speed and the pressure? So we're not worrying about volume and temperature. We're just focusing on the moles, the speed, and the pressure.
Because here's what I have in my notes. If it says the volume and temp are kept at constant, but we don't have any, there's constant temp
Mm-hmm.
and there's constant volume, but there's nothing that's both at the same time.
Do you have anything in your notes about average molecular speed?
There's molecular speed.
Okay, this might be
I
it.
stopped taking notes.
What about this?
Higher molar mass is slower.
Yep.
Well, I know for B, increasing temperature of container. If you increase temp, increased temp equals increase in kinetic energy.
B would
Which
be-
means
B would
faster.
be B decrease.
Why would it be decreased?
Because if you're increasing the temperature, you'd have a high temperature, and then you'd have a low pressure.
This says fixed volume though. At constant volume, pressure rises as temperature rises. That's Charles' law.
Thanks.
And that's saying fixed volume, so that's constant, increased temperature. I think it would cause the pressure to increase. It'd be A, because it's Charles' law.
Well, if we had like a balloon and it was in a room that was like 68 degrees and then we put the balloon in a room that's like 120 degrees, what do you think's going to happen to the balloon?
Pop.
Yeah. And that's because when you increase the temperature, I believe you're also increasing the pressure. Because when you're increasing the temp, the molecules are moving around faster. And so that would create more, movement, pressure, all that.
Yeah.
So we'll say B is then.
Could be as A. Then I'm going to look at C. Decreasing a fixed volume,
Decreasing
decreasing the
the
temperature, and keeping all other conditions the same will cause the average kinetic energy sample to increase. That's another increase. So something's wrong. No, wait. Decreasing. Oh, this says decreasing the temperature. This says increasing temperature equals increase in kinetic energy.
Mm-hmm.
Higher temp equals more energy. So that would make sense. It would be. So it would be B. Okay, so now. It says volume and temperature are kept constant. They can average molecular speed of molecules.
So we're back at A now?
Yeah.
Okay. There was something in your notes that you had, I think it was the next page. Yeah, this
Higher
right
molar
here.
mass equals slower.
Mm-hmm.
It'll decrease and would the pressure stay the same?
Well, we already used
Yeah, you
increase
used-
and decrease, so one of them's remain the same, one of them's insufficient data.
Oh, so each one has to be.
Yeah, it says
Different.
using one of the four options.
Gotcha.
I would assume the pressure. I don't think we know enough to find the pressure because nothing says anything about it.
Well, if the temperature and volume are kept the same, then the speed won't really change in the molecule. Because if you add moles to a thing, like it won't change the speed at all.
Oh yeah, you're right. Because we're adding moles, but the molar mass is what affects the speed. So if you're just adding moles,
Yeah,
the molar
so-
mass stays the same
Mhm.
regardless of how much you have.
So then
So-
I think
So
the
that
first one's
makes
C.
sense.
The first one's C, and we don't know. We can't figure out the pressure,
Yeah.
which makes sense because nothing in our notes says anything if volume and temperature are the same.
Right.
All right, and next is another Use one of the 4 options. Specific heat of water is higher than the specific heat of iron, and the temperature of 100 grams of water will rise blank and that of... What? Do we ever talk about heat? Oh, heat's chapter 6.
So now we're looking at specific heat.
Which we literally are still going over as of
Okay.
right now.
When is this in class? Like, when do you have this?
This will be Thursday.
Okay.
Well, we know the diffusing slower is, for number 4, isn't that N2 and HCl? Because that was the one on the quiz, wasn't it?
Whichever one's heavier. So I know N2's, HE's a small molar mass.
Mm-hmm.
O2 would be like 30.
Oh, it was N2 and then CO2, but CO2 is not one of the answers.
Yeah.
So it's definitely N2.
HCl would be like 18. So it's definitely not O2. Or actually, it could be O2. I have to know, what's the molecular mass of
Here's
CH4?
what I'm gonna do. Oops.
So I don't know off the top of my head.
Is N14?
I can kind of look at the periodic table here. So we have a carbon, and then 4 hydrogens.
So yeah, you're right, it's O2, right?
Yeah, so O2 is definitely one of them.
Yeah, what is the roughly, like, the molar mass of CH4?
It'd be like 14.
Yeah.
Or, sorry, it'd be like 16.
Oh,
yeah,
CH
16.
before.
And then N2 is
16.
one of them also, because that's 28. Or, I can't count today, 20. Oh, that is 28 now. And then HCl, that's also one of them.
What about O2?
Yes.
And helium?
No.
No.
That's 4.
What's CH4 again?
16, I think.
4, it's around 16-ish.
Yep.
And then HCl would be 30, oh, well, it's already 35, so yeah. Oh, wait, diffuse is slower.
Yeah, so
Yeah,
those are
yeah,
all
so it
heavier.
would be heavier. Okay.
Yep.
Alright, I still want to figure out 3 though. When 2 bodies at different temperature are connected with each other, heat will flow from one body to the other until they are both at, well, it's not faster or slower temperature, that doesn't make sense. Wouldn't it be lower? Because if heat's escaping from one. Oh, until they're both at the same temperature.
Mhm.
Wouldn't it be same?
I think it might be same.
When 2 bodies at different temperatures are in contact. Because that's like that, you know, where like the oceans meet rivers and it's that weird like mirage like thing.
Mhm.
Wouldn't it be the same temperature? Because
Think
hot
so.
would turn the cold back. They would like.
Now you're throwing geography. You're mixing like rivers and oceans with us now.
Okay, the way I'm thinking about this, it's like, okay, the specific heat of water is higher, so that is like up here. Iron is like down here. And we have the same mass, 100 grams, same amount of heat applied. This is higher. So which one is going to take longer to get to, water or iron? If we're using the same amount of heat and the specific heat is higher for water.
Are you on A or B?
A.
Oh, we're on B.
Oh.
We're all talking about B.
Wait, what did you guys put for A?
We haven't.
Oh, okay.
Well, wouldn't water have the higher specific heat though?
Yeah.
Oh, well, then we were on, oops, sorry. When 2 bodies at different temperatures are in contact. Oh.
Because like wouldn't heat like balance out the cold and like then they'd just be the same at that one area
Yeah.
where they touch.
Right.
Yeah, so B is definitely C. But then like you said higher.
Well, the specific heat of water is like, if it was on like a graph, it would be up here.
Mhm.
Iron would be down here, roughly. Same amount of heat, same mass. Which one is going to reach the specific heat faster if we're doing the same amount of heat? Like, think about.
The water, right?
In the water.
I'm not sure,
Water
because,
is
like,
higher than the specific heat of iron and the temperature of 100 grams. Of
if,
water
like, this is
slower.
If we have like a thermometer and like the specific heat of water is here, iron is here, and we're gradually raising the temperature, which one is it going to reach first?
Iron.
Yeah, because it has a lower specific heat. So if we have the same amount of heat, it would reach iron first because that is a lower temperature.
So the answer's slower.
I would say so.
Okay.
Does that make sense to you
Yeah.
guys?
I mean, he doesn't grade these as, like, he always grades it for completion, and then,
Gives us the key.
like, yeah, we get the key later on, so.
And if you haven't learned that in class, it might be
We haven't.
clarified later. Okay. Okay. So now we're on to some word problems. Fun, fun.
This is so long.
It's like 47 questions, I think.
Wow.
1 on 5.
But this will be really nice when you're studying for the final.
Yes.
Yeah, I'll be word for word, to be honest. Most of the stuff he puts in the test are
And
exactly
he
the same.
circles the ones that will be on there, so.
Yeah. He's honestly like one of the easier teachers I've had.
Yeah. Who do you have?
Lee, it's kind of hard to understand, but like,
He's so cute, though. He's literally such a cute man. Isn't this just P1, T1, no. T1, V1 divided by P1?
for number 5,
Yeah.
well, we don't know
Because we're trying to find the new temperature.
P1 V1 over T1
Yeah, that's what I mean.
equals
Mhm.
P2 V2.
P1, V1
T2.
over T1 equals P2, V2 over T2. So then we just like plug in this stuff.
Okay.
6.38 times 1.55 divided by, 20.5. We have to do that in the Kelvin.
Good catch.
Which would be 293.65 equals second pressure is 1, the next volume is 7.95, and then we don't know what T2 is. So then to solve for it, 6.38 divided by 7.95, right? Nope, I'm not doing that right. Okay, I forgot how to do it. I got the right answer. Did you guys get the right answer?
No, I didn't get it yet. How'd you do it?
So, do you have this done so far?
Yeah.
Okay, so then what you do is you multiply those together, whatever answer you get there, then you divide it by 293.65, and then because T2 is on the bottom, you're going to take this number, 795, and divide it by whatever this number is.
Divided by that whole number that they give you?
By this whole number that you get, yeah.
Okay.
So you do 7.95 divided by whatever the answer was. It was like 0.033 or something like that. Because then if you were to do that and like actually write it out, then it would be left alone. So then you'd have to divide it and then make T2 equal. And that's 236.
Is everybody following?
I love math.
Okay.
What number did you put? Oh, 6.38. Did you not?
Yeah, that works
It's
too.
okay, it's okay. I know, but I thought for some reason it was like 0, and I was like,
Oh no.
I was like scared I wasn't gonna get this answer. I was like, what?
Yeah, that should work. Okay. And so what units should we always use for volume?
Liters.
And then for pressure,
ATM.
for temperature?
Kelvin.
Yeah.
If it's, so on the quiz yesterday, there was one that, like, it was like 218 m cubed. How do you get m cubed to liters? I completely spaced out to do that.
M cubed?
M cubed.
Oh, cubed. Oh, okay.
Mhm. Do you remember that was on the quiz and I was like,
Yeah.
I forget how
That's
to do
what I
this. I had no idea how to do it.
Was it
so I'm
centimeters
sure I
cubed or was it
No,
meters?
it was meters cubed.
It was
Okay.
like 200 and something meters cubed.
So
Yeah, it was
meters.
like 218 or something like that.
So 1 centimeter cubed equals 1 milliliter. So I think then what you could do is convert your meters cubed to centimeters cubed, and then whatever that number is would be equal to your milliliters.
Gotcha.
Yeah, I didn't do that, so I definitely got that one wrong.
Yeah, that's a conversion that I always forget about.
Exactly, I
Yeah.
completely forgot about it. I'll write that up here. I'm gonna write that in my notes. That's how I do my notes. There's blobs everywhere. Okay.
Yep.
So next one, did you get it?
Yeah.
Okay. Good. What is the mass of nitrogen gas? Is this the normal
That's
gas
the-
constant?
So I think this one is,
PV equals nRT.
yeah, and then it's, you change it to P, or N equals RV over TP.
Yes.
Mm-hmm.
So for R, we get 0.082057.4. And then temperature would be 24.85 times, oh, no, plus 2, so 3.5, which would be 298. And then divided by pressure, which is 19.1, and volume is 80.0. Do you guys know, does Dr. Lee want it just 0.0821, or does he want it like Alex, where it's 0.0820574?
Just 0.808206.
Okay, because I've just been doing the complete what Alex has, because
Yeah.
that's what I did for like 7 problems straight, so now it's like ingrained in my mind. I don't think I got the answer right. But I don't know what I did wrong. It's 298.
I think we have to take the nitrogen molar mass,
Yeah. That's-
So what do you have to do?
take the nitrogen molar mass and then multiply it times whatever answer you get. Like, whatever answer you get from the equation.
Right.
Multiply times molecular mass.
Which
Yeah.
would be what?
Nitrogen gas, so that is 14.01.
14.01?
Yeah.
22.
Right, so why did you do 28.02 instead of 14.1?
Yeah, it's fun.
Because it says N2.
Mm-hmm. Because, yeah, it's diatomic.
So we take this number and then we multiply it by what?
Did
So
say
if you want to
22?
just set it up like a conversion, N is the number of what?
Moles.
Right, so what did you guys get for the number of moles for this?
0.0160334.
What did you get? Did you guys get that answer?
Did you say 0.0016?
No, I just got 0.0. Wait a minute, hold on.
I got 0.
Oh, I did RT over PV. It should be PV over
Yeah.
RT.
Mm-hmm.
That's what I did wrong.
Because I got a different answer.
Yeah.
So let me know what you guys get.
That was a silly mistake. I was wondering, I was like, why is this answer just so wrong?
I got a huge number.
What'd you get?
Pressure.
Oh wait, oh I just messed it up 1 sec.
Yeah, I got like 790.
Here.
Okay, now we do this. Equals that divided by. I got 62.4869.
I got 1750. Which
I
would
didn't know
be,
I did either.
I got the answer.
Oh, the final answer? Okay.
So we take this number, you said, and we multiply it by
So we're going from moles to grams.
Is this
So-
moles N or N2 as of right now?
N2.
So then we want 1 mole, and then N2 would be 14 times 2, which is 28.
So then if we're setting up like a, what goes on top?
28 grams.
But did everybody get around 62 for the moles of N2?
Yeah.
So we multiply that by 28, and that should get us our answer. Because that doesn't, how would that?
Yeah, 62.4 times 28. And then you take the scientific notation of it.
Yes.
Right, and how many sig figs do we need?
Are you confused? Is it 3 or 4?
Well, this is
It would be the lowest number of sig figs that you have in the
It's always the lowest.
So that's why the answer is in 3.
You figure it out?
Yeah. My number, I said it the same way, but I just typed in this huge number. Right.
So since it's 2:30 now, do we want to just keep going, or do you want to do stuff from like each section? Or do you just want to just get as much done?
Let's just get as much done.
Okay.
I'm feeling that.
Okay, that's fine.
I feel like I'm confused about the stuff we learn now.
Yeah,
and
rather
like,
than
all the
old
other
stuff.
stuff I'm like fine with.
Okay. And then we can always go over it next week too if you guys want to meet during finals week.
Okay.
Our finals are on Wednesday, so
Oh, okay.
at 12. So that would, that would help if we could meet at the same time Tuesday. Would that work for you?
Possibly. I'll have to double check.
Okay.
Because I know I have a couple finals on Tuesday, but
Are you one of the tutors who signed up for the SGA thing on Sunday night? No?
I don't know what that is.
We're hosting basically like a study session at Neuer, and there's
Oh,
so far
really?
9 tutors who are
Oh,
going to
okay.
be there. So I didn't know if you were going to be one of them.
I didn't
'Cause
even
I have
know
to
about
stay
that.
there. It's from 9 p.m. till midnight.
Okay.
So I have to stay there until midnight, so I'm just going to be doing stuff like this.
If
but
you sign up, do you stay the full 3 hours, or do you just?
I
kinda-
have to because I'm in SGA, so I like have to stay there. But no, if you like go there, anybody can go there, but it's more geared towards freshmen. But and you can leave whenever, whatever. But there's supposed to be 9 tutors so far, so I didn't know if you were one of them. You should have gotten an email about it.
Oh, maybe I'll have to check back through my email and see if I got it.
So the equation for this is V equals nRT over P. Almost positive.
What'd you say?
V equals nRT over P.
And you got that just by manipulating the PV equals
Yeah.
nRT, right? Yeah.
And then to find N, or first you have to find the ratio, I think, that we would get. So if we're trying to find CO2, leave a CO3.
So we're looking for leave CO2.
So the ratios we Yeah, for these you always have to find the ratio first. And the ratio you find by like looking at the equation. And since they're looking for CO2, and like in the equation there's no or coefficient for CO2, and then you look at CO3, and there's no coefficient for that, so it's just 1 over 1. And then you take that later to multiply. It sounds confusing, but it's really not that bad. I know how to do this one.
So do you guys know how to do this one? Okay, so do you wanna
Yeah.
go step by step?
So first we find moles of HCl. So the mg, I don't know how to convert that to grams though.
That would be milligrams. So we would convert 605 milligrams to grams. So if we set that up, we do 605 milligrams times your like fraction. So what goes on top?
Grams.
Yeah. Then milligrams on bottom. And so how many milligrams are in 1 gram?
1,000.
Mm-hmm.
So it'd be -3 or 3?
You could do, if you're doing on the top with the grams, it would be -3.
Like it's -3 and okay.
Yes, yes.
So then from 1 gram, that's it?
So that would be, we converted the mass of HCl to grams, so now that is what?
Is that 0.605?
Mm-hmm.
Okay.
Oh, it's
So then-
1,000.
So then once we have the grams, then you just find the moles of that, and they give you the molar mass of HCl, which is 36.461. Because since that's grams.
So now you can set up another conversion. So we're multiplying 0.605 grams times what over what?
Would it be 36.461 grams on the bottom?
Mm-hmm.
You're trying to find moles.
Right.
And then are we done with that?
And then you basically just like plug that in. So now that you have V equals nRT over P, so now you have N, and they give you, well, R is a constant, T you have, and then P is just over 1.
Wait, what did you get? You got...
What did you get? What did you guys get for the number of moles?
0.016.
I did not get that. Okay, so 0.605 divided by 36.461. I don't know what I did earlier then. So once you have that, what do you do?
So then you just take the N, and then since you have R, which is 0.08206, you just kind of plug in the numbers. And then T you convert to Kelvin.
Right.
And then pressure is just 1. And that should give us...
I got 0.4222.
Yeah, that's what I got too.
So what do we do wrong?
Okay. I think we're close.
Wait, we just found... How did we go from right here? This is grams of HCl,
Mhm.
mole HCl. So we just did HCl instead of CaO.
Right.
So then we should put 2 mole. This should continue in because there's 2 moles right there for HCl.
Mm-hmm. So we got the volume 0.42. Is that what you guys all got?
Yeah.
The answer, I mean,
I think it should be divided by 2.
Right. The answer is
Yeah.
0.21. And do you know why we divide it by 2?
Well, this number, it's because our n is wrong. Our n should be...
Well,
I don't know if our end's wrong.
Yeah, because the way we ended it was with HCl, but we should end with CaCO3.
No, we're looking for CO2.
yeah. Oh, yeah. We are looking for CO2, and
Well,
so
still
but
the case is 2, so there's 2 moles of HCl, so then we got to continue this thing with 2 mole HCl on the bottom, and then 1 mole of CaCO. There's CO2, so then we end up with CO2. So it should be 0.
well, the reason we used HCl for the equation is because that's the mass that we have. And so we end up with 0.42 as a volume. We have 2 moles of HCl on the reactant side, 1 mole of CO2 on the product side.
I
So
got the
what
right
you can do
answer.
is just divide it by 2.
Yeah,
So
but I got
is
the
it-
right answer, because
Okay, yeah, same thing. Yep, dividing by 2, right?
So would it just be like the change of the ratio then?
Mm-hmm.
Okay.
Right. But yeah, we had to use the HCl because that's the mass that we were given. So you just divide it by 2 because we have 2 moles of HCl and 1 mole of CO2.
Okay. That makes sense.
that was frustrating.
Oh, okay. See, I took CaCO3 as a ratio. So I had 1 over, I had
Okay.
1 over 1.
Gotcha.
So for the ratios, would CO2
So-
be on the top and
so-
then
CO2's on top.
HCl on bottom?
Yeah, so it'd be 1 over 2.
Okay.
Mm-hmm.
Because they gave us HCl.
Yep. The word problem is just saying that the limiting reagent is HCl because it says an excess of CaCO3.
Yeah.
So that doesn't really factor in because we know limiting reagent.
So basically you just do everything else and then at the very end you just multiply times 1/2.
Mm-hmm. Okay, so B. Suppose the carbon dioxide in part A was collected over water. What change would be made in the pressure value in your calculation?
Wouldn't you just change it from 1 ATM to now 45.5 divided by 760?
Yep, that's one step. And why do we do that?
Why do we do which part?
Like, why are we converting?
Because we need it in, not that.
We need an ATM, yeah.
Oh, yeah, and the temperature stays the same. Equals divided by, it'd be 45.5 divided by 760, right?
Mm-hmm.
Nope, I got the answer 3.52, so unless I did
3.52. Right. 45.5 divided by 760.
Yeah, and I just plugged it into the whole thing.
Well, all we're looking for is what would the pressure be if we were to use this in the first equation. So the pressure was...
Oh, I just found the volume, that's what I did.
Mm-hmm. So the pressure is 1 atmosphere in A, but if we changed it to collecting over water, how would that affect the pressure is basically what we're trying to solve for here.
So then we take in, if you divided by 1 divided by 45.5, and then you took that answer and then plugged it into our last equation?
We don't even need to plug it into the equation because all it wants is what would the pressure be. So we don't need to do that. It's just asking what would the new pressure value be. But it's not
Oh.
asking about anything else. So,
So we don't even need temperature then?
nope. Nope.
And 0.94 is where you're supposed to get?
Mm-hmm. So what do you get when you convert 45.5 millimeters of mercury into atmospheres?
What we get?
0.59.
0.059.
Mm-hmm.
86. It'd be 0.060.
Right. So then, what do you have to do to change the pressure? We're going from... There's just one more step that we have to do.
I don't know this part.
0.00296.
So for this,
Take like, makes sense.
do you guys remember doing this equation? Your total pressure equals the partial pressure of A plus the partial pressure of B, and so on and so forth. So like all of your individual pressures add up to your total pressure. So our total pressure is 1. Because that's what we had in A. Now B is saying we also have the vapor pressure of water. So the pressure in A is of CO2. The volume of CO2 is produced at 1 atmosphere. So now,
So that equation, like, I don't understand where, like, you get 3 pressures, you know?
right, okay, so I'm trying to explain it. So we have 1 atmosphere as our total pressure.
Mm-hmm.
And what we're changing now, this is kind of where I'm at. So this is our total pressure,
Mhm.
and that's equal to the pressure of CO2 plus the pressure of water. This is changing because we're adding the partial pressure of water, so now our total pressure
So it's just the 0.06 minus 1.
yeah, exactly. Because this vapor pressure of water is now a partial pressure because we have more than 1 pressure. So what we're trying to find is the new pressure of CO2.
Okay, I see what you're saying now.
Right. So now it's just 1 equals.
It took me a second to
Yeah.
realize.
Yeah,
It was like
I-
easy subtraction.
And I'm like,
yeah.
I like it's just subtraction, but I don't know how to word it. But yes.
So 1 ATM equals,
So 1 equals the partial pressure of CO2 plus 0.06, and then, like she said, you just subtract it.
I got hit out right now, but
Okay.
thank you for your help. It was much appreciated. So are we gonna meet next week, or should we?
do you have all our emails? Are you allowed to have that?
Yeah, I have all their emails.
Then if you want to email us,
Yeah,
and say
I
what worked for
will
you.
figure out my life and let you know. Is there a certain time on Tuesday that works for you guys?
I'm free anytime after 12:45. Or
That works
1:45.
with me.
Okay.
I don't have any finals on Tuesday.
You actually have any
Because she's studying.
I should be good on Tuesday at some point, so. I did Wednesday, I can't remember this. So Tuesday,
Or even Monday. I mean, Monday works for me too. If you guys can.
I think Monday.
oh yeah, well Monday we're open normal hours until 5. I might have an opening on Monday, if that works. But if not, we can just do, what time on Tuesday, did you say?
Anytime after 1:45.
Okay,
How
so,
we didn't even learn how to do this one.
Wait, no.
I know, I'm looking at this
We
next
don't have
one. We didn't even
class
learn how
next
to do
week,
that.
No, I don't even have, no, never mind.
so do we want to do Tuesday at 2 or 3?
It's fine with me.
Two?
Two's fine. Yeah.
Okay.
So normal time.
Yeah.
Oh yeah, normal time, alright, sounds good.
Do we have to make an appointment or do we just?
Nope, I just fill it out for you guys, so all you have to do is show up.
Thank you.
Thank you.
Mm-hmm.
Alright, I will see you guys later.
Bye. Have a good one.
See you.
When's our chem final?
Wednesday, 12 to 2.
Gross.
Yeah.
So I would say, after you guys do this, and if there's anything that you guys have questions on, like circle it, and then we can go over that next week.
Okay.
And then like, if you get a review study guide from class, like,
This
do
is
that,
This
and
is
this
the
is
review
review
study
study guide.
oh, that, this is,
Yeah, so
okay.
this is it. So like once we do this in lab, then he'll give us the key and then circle
Which
the ones
can-
that we want.
I mean, do you guys have to,
Okay.
do you have to leave, like, what, we never learned how to do number 8.
Yeah, I don't know.
I have no idea how to do it.
I can see myself sitting in the lab.
Yeah, 8 and 9.
8 and 9. Can we just do 8 and 9 real fast, please?
Yeah. So number 8, how much heat evolves from burning 16.4 grams of sulfur, S8 in air? Oh, okay.
I mean, I could make guesses, but
I will look through your notes for equation.
we
That-
haven't gone over this.
Okay,
at all.
then I don't know what it is. I just know that there is an equation for it,
Okay.
but I don't remember off the top of my head. Yeah. But this shouldn't be too bad. It should just be kind of like a plug and chug type of thing.
Okay. Sounds good. There's actually a lot from this like section that's on there. It'll probably be like this, literally the same thing now.
Oh, yeah.
Yeah, and this might help you on your Alex homework. So
Yeah, I have a lot of that too. For sure.
Me too.
I just emailed him about like if he needed to do the whole pie,
Yeah.
and when he like responds to me, I'll email you.
Yes, perfect, thanks.
Yeah.
isn't it like you get 50% of credit if you do it on time, and then 50% if you complete it overall, or something like that?
I don't know because my math class is like if you miss topics during the week, like it doesn't matter at the end. Like you already have your grade, but he hasn't put any of our Alex grades in yet. So, and it's like 60, there's like 90 points and 60 is Alex and 30 is attendance. So I'm wondering if you don't do all your Alex, if you even get like all the 60 points.
I would say your best bet is just to complete it.
Yeah.
That's what I'm doing.
Just getting it done.
Yeah,
Unfortunately.
Right.
I understand how much of a struggle Alex is, because it's just,
I got so frustrated that I'm just like, I'm not doing it.
I just don't think
I'm
it's
not
very
doing
good
it.
for learning, because you just feel, I feel like pressure doing this, and I'm just like helping you guys do it.
Yeah.
And it's like, oh geez, if I get this wrong, then I have to go all the way back to the beginning.
Yeah. Especially chemistry too, like
Oh, yeah.
one wrong thing and it's like,
Yeah.
you're done.
Yeah.
If you round your answer to like 1 point of it.
Well, that's why this
Yeah.
final, like, I know I'm not gonna remember how to do every single thing in that packet. There's no way.
I think it's just
It doesn't matter how much I
random
study or
equations.
redo it. It's just.
I'm like, no, for
I think once you go over it and you go through like the stuff from the beginning, it'll come back easier than you think, and then
I hope so.
you're probably going to be given the constants on your. Are you going to be given the constants and stuff on your test?
It'll probably be that right there.
Okay.
It's on it.
Then you don't have to remember that, and then all good things.
Yeah.
All good things.
We'll
Thank
try
you.
it.
Yeah, no
Yeah,
problem.
thank you.
See you next week.
See you next week.
Thank you.